All right, welcome to Solving Rational Equations, Part 1. And I put an example here because I really want you to know what is a rational equation. Well, first of all, you can see it's an equation because it's got something equals something else. Okay, so that's why it qualifies as an equation. And you see how we have these rational expressions, and we're not just talking about fractions, we're talking about where you got like an x as part of the denominator, okay? So that's why it's different from equations you've seen before that involve fractions. This time we have fractions, but we got real rational expressions because we got the x's as part of denominators. However, that being said, the strategy we're going to use is not really any different from what we've done with fractions in the past. Step 1 is to get rid of the fractions. Okay, so that's, I think, the best thing to do to start with. So get rid of any fractions. And we use multiplication to do that, which you'll see in action in a second. Okay, but once you've done that, then what do? Well, you solve. Okay, so once you got rid of your fractions, then you can just solve your equation. But there is an important third step. Okay, you have to make sure that your answers are acceptable. So you have to check. Checking means going back to the original and making sure, for example here, that x wouldn't be 0. You know, 0 would cause us a little bit of hardship here because it's actually a non-permissible or a restricted value. Okay, so that's what we talk about with checking. You want to make sure that it's an allowable answer. So let's try these steps out on this first example. So I'm going to use multiplication. So how am I going to get rid of all of these fractions? Well, I look at my denominators, and I'm basically going to multiply by the lowest common denominator here. I see a 2x, a 4, and a 4x. So I think I'm going to multiply everything by 4 because it's divisible by 2 and 4. And then I also need an x in that. Okay, so I'm going to multiply everything by 4x. So here's what's happening, and I'm going to write it all out so you can totally clearly see why this gets rid of the fractions. Okay, so I got 4x times the first fraction, and plus a 4x times the second fraction equals 4x times the last fraction. Okay, and these 4x's, they're like over 1, right? So that's why I wrote them so high, because they're actually numerators. I didn't want to write them over 1 because it gets kind of messy then. But anyway, so what can we do here? Well, look at this. The x's certainly cancel. And the 2 divides into the 4 twice. So I'm left with 2 times 5, which is 10. Well, that's not too bad. Then over here, these 4's cancel. Now the x doesn't cancel, but I do end up with 3 times x. So that's just 3x. And look at the guy on the right. The 4x's totally just cancel, and it equals 9. So now I just finished solving. I'm going to take 10 and subtract that from both sides. Okay, so that leaves me with 3x's equals negative 1. Then I divide by 3, and there's my answer. I just make sure that that's okay. And when I look up here, yep, negative 1/3 isn't causing any zeros in the denominators. So I'm pretty happy about that, and I'm considering this a very good answer. So now I'm going to take a break from that and move on to the next example. Clear the screen. Whew, and away we go. So we've got x divided by x minus 5. And I got minus 3 divided by x plus 1. So this is a lot more to it, my goodness. And then we have 30 divided by x squared minus 4x minus 5. Okay. Well, before I go crazy here, I'm going to go ahead and factor this trinomial. Generally it makes life a lot easier if you can take these things here. If they factor, go ahead and factor them. You'll see usually it becomes very clear that's what you're supposed to do. So I'm going to go x times x, then I need a number times a number to make negative 5 that adds up to negative 4. So I'm thinking negative 5 and positive 1. Now take a look at this. X minus 5, x plus 1. And look at these fraction denominators over here. X minus 5, x plus 1. So in other words, and let's scribble this out. In other words, if I just go ahead and multiply everything here by x minus 5 and x plus 1, guess what? I'm going to get rid of all my fractions in one swoop. Now, most students, they don't write out every little step here. So I'm going to try and do it without writing everything out as well. What I'm going to do is note to myself that, yes, x minus 5 would cancel with this x minus 5 out here. So all that's left is x plus 1 timesing the x that's on top. So I'm just going to write that down. I have x times an x plus 1. Then I have minus, right? There's a minus here. Now the x plus 1 is now going to cancel with the x plus 1, leaving the x minus 5 and the 3. So I'm just going to write that as 3 times x minus 5. Okay, equals. Now the one that's really good is the right side, because look, x minus 5 cancels and x plus 1 cancels. All that's left is the 30 that's on the top. All right, so now, next thing I got to do is expand out my bracket. So I'm going to have x squared and plus x. Then I have minus 3x and plus 15. Okay, so far so good, and then there's 30. And so let's see if we combine some like terms here. X squared minus 2x. And let's bring that 30 over to this side. So I'm going to minus 30 from both sides. So this actually becomes minus 15. And the only way we can solve this is to try and factor it. Okay, it's the only method we know so far. Well, guess what? That means that they're always going to factor in this chapter. So I need factors of negative 15 that add up to negative 2. So I'm thinking negative 5 and positive 3. So here's what it would seem my two solutions are. 5 and negative 3. Now here's the problem. When I go back now, remember you have to check, right? It's so easy to want to skip that, but you have to go back and check. Is 5 okay? Whoops, 5 isn't okay. Look at here and here. 5 is bad. So here's what we have to do. We have to reject it. So put an X through it. Some people even write over top or next to it, reject. Okay. Negative 3, on the other hand, doesn't cause any trouble. Okay, there's no zeros as denominators, so this one's good. And that's all there is to it. What I'm now going to do is I'm going to stop because I don't want to drag this process out, and I'm going to come back with other stuff in a little while.